Hi guys, welcome back to another video. So this video is going to be about binary trees and binary search trees. Okay, so first of all we'll talk about binary trees. Okay, and then we're going to jump into a more advanced topic, which is binary search trees. So to understand binary search trees, we should have a pretty good understanding of the fundamental of binary trees. So what is a binary tree? A binary tree is a hierarchical data structure in which each node has at most two children. Okay, so here referred as left child and right child. Let me elaborate. So here you can see here's the root node. Okay, so the first node in any tree from which the tree begins is called the root node. So as you can see, 2 is a root node. Okay, root node, and then it has two children. A node can has at most two children. Okay, so here is 5 and here is 7. Okay, so then these children are together are known as siblings. Okay, so these two are known as, these and these are known as siblings. Okay, siblings. So these two nodes are referred to as siblings. Okay, so let's change the color. And now this node then gives so this node has two children, which are 2 and 6, and this is how the tree works. It has at most two children. The two children are called siblings, and these are connected to a bond through a bond called edge. So this thing is called edge. Okay, so the node which starts the tree is called the root, and then these are connected via edge, and the two nodes that are given that are of child of the same node are called siblings. And at the end of the node you can see these nodes are called as leaf. Okay, these nodes are called leaf. So here these are basically some fundamentals about binary trees, and then there are binary tree traversals. Wait a second, let me make it more clear. So this section is known as, this and this are referred as siblings. Okay, these and these. Okay, these two nodes, and then this node is referred to as leaf. Okay, so there are binary tree traversals. So let's talk about traversals. So the way we get around the tree. Okay, so the first is in order traversal. Okay, change the color so it's clear. So the first traversal is called in order traversal. So what we do in this type of traversal, the left subtree is visited first, then the root, and later the right subtree. Means that we will go to the most left subtree. Okay, so for here if we go the first we'll start with 2. Okay, then we'll go to the root node, which is 7, and then we'll go through 6. Okay, and then we'll pass through the other node. Okay, so this is how basically the in order traversal works. We first traverse around the left node. Okay, then we go to the root one, and then we traverse to the right node. Okay, and then the traversal goes to the root node. Okay, and this is how this in order traversal works. So how is pre-order traversal? So let's talk about this. In this traversal method, the root node is visited first. So the root node for here is 2. Okay, and then we traverse to the left subtree. Okay, so this is this 7, and then 2, then we'll traverse about 6, and vice versa. So this is how we traverse through in a pre-order traversal. So let's talk about post-order traversal. In this type of traversal, the root node is visited last. Okay, so first we visit the most left node over here, which is 2. okay, and then we visit the right node, which is 6, and then we visit the root node, which is 7, okay, and then we move around the other nodes. Okay, so we are referring to referencing to this subtree over here. Okay, so it is not that complicated. So first of all, we go to the left node, then the right, and then we lastly traverse to the 7, and then we go to the other part of the subtree. Okay, so this tree is divided into subtrees. Like this is a subtree 6, 5, 11, and 7 is a subtree, okay, of this root node. Okay, so this is how we move around the tree. So let's see the code of this so you can understand better. This is a theory based means you should understand that the left subtree is visited first, then the root, and then the right subtree. So I know many of you will find difficult to understand like this, so let's go to the practical representation via C code. Let me open my Sublime text code editor. So here I have the code for the binary tree. So first of all, we define the construction. Okay, so here is the skeleton for tree. So here we have created a structure for the node in which we have int data, and there is a left node and a right node. Okay, so then this is the structure for our node. Then to create a binary tree, first we have the create function in which we push the data for which we are going to allocate memory. Okay, by using the malloc function, which takes the standard library. And then after we have created space for our tree, then we push the data to a node. Okay, so then the left section of the node is null and the right section is also null. Okay, and then we simply return the node. So this is the recursive algorithm to create a tree. Okay, so then there are these 3 traversal methods, okay, in which we first go to the leftmost node, and then we go to the right node, and then we basically go to the root node over here. Okay, so this is how it's like. So you can see post order in which we visit the left tree, then the right tree, and then finally the root node over here. So this is how this post order traversal works. The in order traversal works like this. First of all, we go to the left node, then we simply print the data, then we go to the right node and we print the left node, then we go to the root node, and then we go to the right node. So this is the recursive algorithm. We first went to the left node, then we simply printed it out. This is how the recursive algorithm of these 2 traversal method works. So now we have the pre-order. Okay, the pre-order traversal, in which if node is null and return nothing else, we will first print the data. Okay, first we'll print the root node, then we'll visit the left node, and then finally we'll visit the right node. So this is how the pre-order works. So first we'll print the node we are at, then we will move at the left, and then we'll move at the right. So this is how here you can see the pre-order. Wait a second, binary trees over here works. So these pre-order in which the root node is visited first, then the left subtree and the right subtree. So this is how the pre-order traversal method works. Okay, so this is the recursive algorithm for that. So now let's create a tree in the main function over here. So to create a tree, we will use the create function we created earlier. We'll assign some memory to a tree, and the root node is 1. Then we at the left side of the root node we'll pass the element to using the create function. Then we'll create a right node, okay, from the root, and we'll pass it the value 3, and then vice versa we'll do the rightest element to the right node of the root node will pass 7. This is how this tree works. Okay, so we are passing some elements like this for to the left node, we are going to the left node, and like you understand how you create an image in your mind. So how this is working, we are pushing to the left and then left, and the leftest node, which is will become the leaf of the tree. Okay, so this is how means we are inserting some data in a tree. Okay, so then we have created the tree, and then we are going to traverse in it. So first we are going to traverse with the pre-order method. So let's open a terminal, let's compile our program. GCC DSA binary trees, not binary, binary tree minus O P5. Now program is now compiling, is now compiled. So let's now run the P5EXE. So here we have the pre-order traversal over here. Okay, so in the pre-order traversal, first of all we visit the root node over here, okay, which was 1, as you can see, and then we traverse to the left element. Okay, then it went to 2, and after that to the left element, to the left of the root node, we created 4, so it went to 4, and then vice versa to 6. After 4 we created a node to the left, to this 4 value, we created 6 over here, so it went to 6. Okay, and then what it did, it then so all the left elements are completed, and now it started to traverse to the right element, which was 9 over here. Okay, so then it traversed to 9, then it went to 3. Okay, so it then got started going to the right, means the right elements. So from 3 to 3, and to lastly we went to 7 over here. So this is how the pre-order works. So now we have the in order. Okay, in which we first visited the left node. Okay, so the leftest node we all know is 6, which is a leaf. Then we traversed to 4, okay, which is the parent node of this. Then we traversed to 2, okay, which was a parent node of this element. Then after 2 we traversed to 9, okay, because all the left elements are completed. So then we traversed to 9, and then we got to the root node, and then we got to the 3 and 7. Okay, so why it first traversed to 9 and then 3 and 7? Because it was basically right child of this 4th, I guess. To the left 2 is it's a child of 2 over here. So this is why it traversed to 9 first, and then it got to the more later right elements. Okay, so this is how traversal works. Okay, so then we see how the pre-order traversal worked. So first it went to the left element, which was 6, then it go to the parent, which was 4, and then we traverse to 9. Okay, because we are not traversing to the root node as we did in order. We first traversing to the right elements. Okay, so we traverse to 9, and then we traverse to 2, and then we traverse to 7, and then 3, and then lastly we went to 1. So the root node is at last. So this is how the post order works. In order, we first went to the leftest element, then we got to the root and to the most right elements, and then in post order we first went to left, then right, and then to the root elements. Okay, so this is how these 3 traversals worked. Okay, so now we know the fundamentals of how to what is a binary tree and how it works, and what are the traversals we use to go around it. So now let's talk about binary search trees. So let's go to my presentation over here. about binary search tree. Here, as you can see, some key points about binary trees. Wait, let me change the color. So in this is a binary tree. Basic is a binary tree with additional restriction. Okay, so it has some additional restrictions than of a binary tree. So here, what are the restrictions? The left child will always be less than the parent node. Okay, so here you can see here is the root node. Okay, and the left child is 3, which is less than the root node to the parent node, and right child must always be greater than the parent node. So here you can see that the right child is 10 and it is greater than the parent node or the root node. Okay, so vice versa, here you can see the right child is greater than it, and here as you can see that this child is also greater than it, and the left child is less than the parent node. So this is basically the fundamentals of binary search tree. But I first introduced to this, then you might have not known, might have not understood it well better, because binary search trees are a bit complex than the of binary trees. So binary trees were basic and we are using in binary search trees. Okay, so what are the some advantages? That insertion, deletion and searching is much faster than of binary trees. Obviously we are organizing data in a sorted manner, in an organized manner, then these operations are much faster. Okay, and then here is a negative point, that we are ordering some elements like this, which will add complexity to it. So what is complexity? I explained it in the first part of this course, which was bigger notation and introduction. So check out this video if you directly jump to this one. And the most important point, okay, is in order traversals results in sorted elements. Okay, so here first we will what in an in order fashion we will go to this node, okay, to the leftist node, which is 1, then we'll traverse to the root node, which is 6. Okay, then we'll traverse to the right node, which is 3, root parent node, which is 3, and to the right node, which is 6. Okay, so this is how in this subtree, this is how in order fashion gave us the sorted elements. So this is how in order traversals results in sorted elements. You can do that for the whole tree, but it's more clear in a part of a tree, which is a subtree. Okay, so yeah, you may have not understood that clearly, so let's go to a practical representation. So I have more. So yeah, so here we have already understood how to basically create the structure. We created the structure, the left and the right node of a, so this is how we created the structure of the node we did earlier. Okay, then we created the create function. We have already talked about that. So we assigned some memory, this, then we return this temp. Okay, so this is the create function. Then we are only creating the in order traversal for this one. Okay, for elaborating, for explaining, because we have to prove this point, okay, that in order traversal gives us sorted elements. Okay, so to prove this point we have created an in order function. Okay, and also try post order, pre-order traversal in this. Okay, and then we have the insert function. So this is most important, which was not in this one. So here we have the node over here for where we are inserting, okay, and the key node. Okay, the key node, if the node is null, then we are going to create the key right there. Okay, so then we are creating the tree with this key as the root node. So this is how some recursions work. Okay, so here if the key is less than the node, okay, so if the means if the element is less than the parent node, then it will go to the left side. Okay, we'll insert it to the left side. Okay, so else if it's greater, then we'll push it to the right side. So this part is most important because it is the purpose of binary search trees. Okay, so and then lastly we'll return the node. So let's get to the implementation in the main functions. So here we first created the structure and gave the value null. Okay, then we inserted the root value, which was 50. Okay, so we inserted the root was actually here, it was actually null. Okay, so then we created the key right there, so and we assigned it 50 over here. Okay, so then we inserted 40 and 70 and 60 and then 80 to the tree. Okay, so now let's go around this tree via in order traversal. I've already explained how in order traversal works. So let's compile a program. So as you can see that we are now moving to the tree with the in order traversal. So first it will traverse first with the 40 node. Okay, so it gave us sorted elements. Okay, so first it went to 40. This is how we organized our data. Okay, if it is left, then we push it to the left child of the parent, and if it's greater, then we push it to the right child of the parent. So this is how we organize our data, and if we are moving through the in order traversal, we are getting sorted elements. Okay, so first it went to 40, then it went to the root node, which was 50 of 40, and then we organized it earlier via this function, and then it went to 60, and then it went to its root, and then finally to the rightest element, which is 80, to the most right element. So this is how the in order traversal work. Okay, so as we have seen earlier in this, that how the in order traversal works. Okay, so first it went to the subtree, then it went to the root node, and then to the right subtree. So this is how we traverse through the binary search trees, and we got the sorted elements via in order traversal. So we have checked this point. Okay, so now yeah, it was it for this video. I hope this video was helpful, and I will see you next time. Bye.